Hi and welcome to this video which is based on working with polynomials. So in this video we're going to look at how we can work with polynomials, and we're going to start with quadratic functions and equations, and then we're going to move on to longer polynomials of degree 3 and higher. So if you haven't already revised long division, I would do that before getting into this video, as we're going to need that for some of our examples. So in this video, we're going to cover examples of how to find a polynomial from a graph using the root, to sketch a graph of a given polynomial, solve cubic equations using the factor theorem. So there is a lot going on in this video which pulls on different pieces that you will have already seen. We're going to start building up with what we know and then apply it to more higher level material. So just to do a little bit of background about the roots, if you're asked to get the roots of an equation, it is the exact same question as asking you to solve the equation. When we're working in algebra, it's more likely that we see the question solve. When we're working in functions or with graphs, it's more likely that we'll see roots of the equation. From the picture here on our right, the roots are where the graph, in this case a positive quadratic, cross the x-axis. So we can see that there are 2 points where that happens, where x equals 3 and x equals -2. These could also be called the x-intercepts, or they may ask you specifically for the points where the graph cuts the x-axis. Do watch out for the difference in questions, because if they ask us for points, our answer should be in the form of points, which should be 3, 0 and -2, 0. So if we are using the roots of the equation to find the equation, we first must make sure we are 100% with how factorization works. So I'm going to work through the factorization method of solving a quadratic equation. So a quadratic equation here is given as 2x squared minus 9x minus 5 equals 0. From this we get a guide number of -10. We get that by multiplying the first coefficient 2 by the last constant, which is -5. That sign is really important. The negative means that whatever our factors are going to have different signs. So working that through, if I multiply 1 by 10 and they have different signs, I can work it through so I get my -9. So my +1 multiplied by -10 does give me -10, and +1 minus 10 equals -9. So our method here is we're trying to work out how can I split this -9x into 2 terms, which I will then which then means I can use grouping. So I'll have 4 terms, so I can use grouping. We've split that -9x into +1x minus 10x. Sometimes when you're doing factorization, you can get a little bit caught up, but I would definitely advise you to double check. Does +1x minus 10x give us -9x, and really focus in on those signs. In this case it does, so my next step is to factorize using grouping. So I group the first 2 terms and the second 2 terms, and then I get x times 2x plus 1 minus 5 times 2x plus 1 equals 0. At this point your check should be that both brackets are the same. If both brackets aren't the same, something has gone wrong. It could be as simple as you haven't taken out the highest common factor, you've just taken out a common factor, or it could be something got to do with how you factorize that guide number. Bringing these together, we get x minus 5 and 2x plus 1 equals 0. What's important to note here is this line here gives us factors. So these brackets, these are our factors. If the question was to simply factorize a quadratic trinomial, this is the point where we'd stop. But we're asking in this question to solve the quadratic equation, so we've one more step to go. So we take each of our factors, or each of our brackets, and we let each factor equal 0, and we solve for x. So we rearrange it to get x equals 5 and x equals 1/2. At this point we have the roots. So that is our process. And what we're going to see now, as we work with the roots of any equation, but in particular quadratic, we're going to do this exact method, but work through it backwards. So, just an overview of what's happened. We start with the equation. We break it into smaller pieces that multiply together. There are factors, and we let each factor equal 0 to then get our roots. So when we use the roots to build the equation, we're going to work backwards. So we start with the roots, we then get the roots into factors, we then get the factors into an equation. So if we let each factor equal 0, the opposite will be true. We're going to rearrange our roots so that it's something equals 0, which will create our factors. And if we were factorizing our equation to get factors, the opposite of factorization is multiplication. So let's see this example in action. Form the quadratic equation with the following roots, 4 and minus 2. So the first step in any question is to write the roots like we would see it at the end of a question asking us to solve. And that is x equals 4, x equals minus 2. Let's keep track of what we have. These are our roots. So remember, we're working backwards. So what we want is to get this equal to 0. So I'm going to subtract a 4 from both sides here. So I get x minus 4 equals 0. Here I get x plus 2 equals 0. So remember, we let each of those factors equal 0. So by that logic, we must have had a factor which was x minus 4. And we must have had a factor that was x plus 2. And they were both multiplying to give us 0. So at this line here, this is our factors. Now, if I want to multiply out that bracket, we split the first bracket, which is x times x plus 2 minus 4 times x plus 2. That equals 0. Multiplying that out, I get x squared plus 2x minus 4x minus 8 equals 0. And we get x squared minus 2x minus 8 equals 0. And we are back to our equation. So hopefully you can see at this point that it is the exact opposite to if we were using guide number to factorize and then solve. So now that we've already looked at some quadratics and you've got back up to speed, let's talk a little bit about polynomials. So polynomials, based on that word, poly means many, nomials mean terms. So these are many terms. So we're talking about when we get into cubics and then x to the power of 4, x to the power of 5, and so on. So there are some rules regarding polynomials. So it's only a polynomial if it has positive powers. So you can see here in the example, I have x to the power of 3, x to the power of 2, an x, which is an x to the power of 1, and then our constants. This is a polynomial. All of our powers here are whole numbers. That's great. All of our powers here are positive numbers. The second rule then is they have to be whole numbers. So if there was a power of a half, so a square root in there, that wouldn't be a polynomial. The third thing is one that we can see from our graph, and that is that a polynomial must be very smooth. There should be no harsh lines or points. So if you see anything that's quite angular, it will not be a polynomial. Also, when we're sketching, and the majority of our sketching will be polynomials, do you remember to keep a nice curve as you're going? No straight lines, no points. So we're going to look at this polynomial here. I've given you a graph and I've given you what that polynomial function is. So that's f of x, the function, is equal to x cubed plus 3x squared minus 10x minus 24. Now, we can tell a lot of information from the graph and we can tell a lot of information about the polynomial itself. Some of that overlaps, some of it's unique to one or the other. So let's start taking a look. There are 4 things that we're going to focus on with our graphs of polynomials. The first thing is the degree of the polynomial. So the degree can be gotten in a few different ways. It is equal to the number of arms, so that's obviously from the graph. If you're counting here, what I mean by arm, I'll draw along this. So this will be 1 arm. Then it turns and I get a second arm. And it turns again and I get a third arm. So an arm is between our turning points. So the number of arms in this is 3. This is also equal to the number of roots. So I can't tell about my roots with the function as it is, but I can from my graph see my roots. Remember that the roots are where it crosses the x-axis. So there's a root, here's a root, and here's a root. So there are also 3 roots, which matches the number of arms. And the last way, which I've done in a different colour, which you might notice is the same colour as our polynomial below, that is where we can take it from the polynomial function itself, and it's equal to the highest power. So in this case, we have an x to the power of 3. 3 is the highest power, therefore 3 is the degree of the polynomial. So all of these agree, and it tells us that we have a graph for a polynomial of degree 3. The second thing we're going to look at is this positive or negative? So there are 2 ways to do this. First way, based on the leading coefficient. So the leading coefficient is the number in front of the term with the highest power. So one way I like to think of it is who has all the power. So who has the biggest power? And here the biggest power is this guy here. And the leading coefficient in this case, there's nothing there, so we know that should be a 1. It's a positive, therefore everyone's going to be positive. So this guy with all the power, when he is positive, everyone is positive. And when he is negative, everyone is negative. Now, be very careful with this. Sometimes students learn that it's whatever that first term is, and that's not necessarily true, because sometimes, and especially at higher level, they like to mix it up, and if that was a negative term, they will put that negative term later on. So don't just assume it's the first term, look for the term with the highest power. So based on the leading coefficient, this is positive. Well, from a graph, I can also figure it out. And the way I figured out from a graph is right arm up means positive, right arm down is negative. Now, I can't show you this, but maybe you can do it. If you hold your left hand in front of the screen and cover the polynomial until just the right arm is showing, what you should see is the end of what looks like a quadratic. And most students are very familiar with quadratics. Positive people smile, negative people frown. So if I cover my polynomial, just leaving that right arm free, I can see that it looks like half of the smiley face, which would have been my positive quadratic. And I can use that fact to help me. If you don't like that, you can always learn right arm up as positive, right arm down as negative. So based on the leading coefficient, we see positive. Based on the right arm, which is pointing up, it is also positive. So we can say that this is a positive graph. The third thing we're going to talk about is our roots. So we worked out our roots already, but just to remind you, they're where the graph crosses the x-axis, and it's when y is equal to 0. So there are 3 roots, and we write them as such. X equals minus 4, x equals minus 2, and x equals 3. Now, sometimes we're given the function of the polynomial in what we call factored form. What we have here is expanded form. With expanded form, it's not possible to easily see the roots. When it's in factored form, it is easier to see the roots. If I wanted to find the roots given the polynomial function, I would have to break it down into its factors and then its roots. So I would use what's called the factor theorem, which we will see at the end of this video. So the last thing that we care about when we're talking about graphs polynomial is the y-intercept. Now, it is not marked here. However, I will tell you on this graph that this is minus 10, this is minus 20. So roughly speaking, that looks about a minus 24. So from the graph, it's where the graph crosses the y-axis where x is equal to 0. But the second way that we can figure out what the y-intercept is, it's the constant in the polynomial. And how we work that out is we say when x is 0, what is y? So we get 0 to the power of 3 plus 3 times 0 squared minus 10 times 0 minus 24. And all we're left with is that constant. So the constant here will always tell us the y-intercept if we're given the polynomial. If not, we can pull it straight from the graph. So when we're given a polynomial graph, when I want to sketch a polynomial graph, I'm going to go back to all 4 of these pieces. Now, before we get into using the graphs and sketching the graphs, I have 2 more little examples like this to go through first. So here's our next example. So we're going to work through this exactly the same way. So surprise, my 4 things I have here on my right hand side that I need to work through: the degree of the polynomial, positive or negative, roots, y-intercept. Notice that I haven't actually given you the function here. It's not relevant. We're going to focus on the graph for now. So anything in blue is not useful. Okay, but I will be able to tell some things, and I'll work with that in a second. So the degree of the polynomial is equal to the number of arms. So let's go back to my graph and count our arms. So 1 arm, turning point, 2, 3, 4. Okay, so it looks like the degree of the polynomial is 4. It should also be equal to the number of roots. So let's go to our roots for a second. So there's 1 root, 2 root, 3 roots. Okay, so it looks like this thing here has caused a little bit of a problem. I'm going to ignore it for the moment. I will tell you degree 4 is correct. The number of roots is 4, although we can only see 3. We'll discuss it a little bit more when we get down to number 3 here. Positive or negative, right arm up, right arm down. In this case, we have a right arm up, which means it is positive. Oh, change back. So it's positive. And our roots, where the graph crosses the x-axis. Now, I know I should have 4 roots, however, I'm only seeing 3. So I'm seeing x equals minus 5. I'm seeing x equals minus 3. I'm seeing x equals 1. Where is my missing root? Well, there is a special case here because this is touching the axis. Okay, so touching the x-axis. And when I say touching, as opposed to going through, okay? So if we look here, the graph passes through -3, so it goes through it. At this point, up here, it's simply touching the x-axis. And when we see that, we need to remember that that actually means that there are two roots there. So there is a second root that is x equals 1. And that's hugely, hugely important. And that's why I would always recommend counting the number of arms to help you with the degree and the number of roots. And you'll see in our next example why that will be the case. Now, here I want the y-intercept. Again, I haven't really got a very good diagram, but I will tell you that this is 10 and this is 20, so this roughly looks about 15. So the y-intercept is 15, so the point itself is 0, 15. Now, I can actually create the polynomial function f of x based on what I have. Using a similar method that we had before for our quadratics, I start with my roots. So I have x equals -5, I have x equals -3, I have x equals 1, and x equals 1. From those roots, I can create factors. X plus 5, x plus 3, and instead of doing x plus 1 times x plus 1, we write this as x plus 1 squared. Okay, so when I have this, I'm not going to multiply it out, but what I can focus on are two parts. So the first part I can focus on are my x's, and that's a squared. So focusing on my x's, I have an x times an x times an x, which is squared. And multiplying that out, I get an x to the power of 4. And that tells me two things. That tells me that the degree is 4, which validates what I've already figured out. And it also tells me that it's positive because it has a leading coefficient of 1. So there's a 1 in front of it, it's positive. So that tells me that it's positive. So two things I get from there. It agrees with what I've done up there in number 1 and number 2. My roots are already given, so this is all part 3. And to get my y-intercept, I do something similar that I did with the x's, but this time I'm going to focus on the constants. So I have a plus 5, plus 3, and a plus 1 squared. So I've got plus 5 times plus 3 times plus 1 squared. And signs are so important here, so we take them all. When I multiply that out, I get 15, and that agrees with my y-intercept. So that is because I'm dealing with the constant term. So I don't know what goes in between that x to the power of 4 and the 15. So I'll have something x to the power of 3, something x to the power of 2, something x, and then my 15. But they're the key pieces, and that's what we're going to focus on. So my last graph, okay, so it should be looking a bit more complicated. So I'm going to count my arms. And looking at my arms, I go 1. So you can draw along with it. So 1, 2, 3, 4, 5, 6. Interesting. It seems to be degree 6, but I'm not sure. Let's count our roots. 1, 2, 3, 4, 5. But there's only 5 roots. Okay, so this is getting stranger and stranger. I have double counted here because there's 2 roots here. But this power 6, or this degree 6, if you think logically, we can't have an even number of arms and the arms pointing in different directions. So this is a little trick, but it's not as important as the other one, so it hasn't been included. So the fact that I have the left arm pointing down and the right arm pointing up indicates that actually there should be an odd number for the degree. So 6 does not seem right, so maybe 5 is correct. Well, there's a reason I left this piece kind of blank, and I'm going to highlight it in a different color. And the reason I'm going to highlight in a different color is this has a flattening, and this flattening is basically the graph attempting to turn like it does at 2, but then changing its mind. So what is actually happening here is this flattening. There are 3 identical roots at this point. So that orange piece there is actually considered an arm. So then adding that into it, I get 7. Based on my new information about the roots, I have 3, 4, 5, 6, 7. I now have 7 roots. Okay, so that all adds up. So what I'm talking about here is I have an x to the power of 7. My right arm is up, so I have positive graph. My roots are, so I have a lot of roots this time. I have x minus 3. Sorry, x equals minus 3. Let me rub that out and start again. So, sorry, I have x equals minus 3. I have x equals minus 3. I have x equals minus 3. So that's 3 roots at that point. I have x is equal to 0. I have 2 roots at x equals 2. And I have x equals 4. And my y-intercept is 0, 0. Right here. There's my y-intercept. So based on what I've just done, we So working this out, we should get x to the power of 4 minus 4x cubed minus 3x squared plus 14x minus 8. Okay, so the last thing I'm going to do, just to double check. Okay, so I have an x to the power of 4, so that's correct. It is positive, that is great. the roots, I've used those, and the fourth thing that was on my list was our y-intercept. So let's take a look at my y-intercept. My constant here tells me it's -8. That means that -8 is what my y-intercept should be, and looking at my graph, somewhere between -5 and -10, maybe in around halfway, so -8 looks absolutely perfect. Sorry, let me clean up this few bits here in case you're taking it down. So that should be a plus here. Okay, so that looks absolutely fine. So in this case, A is 1, B is -4, C is -3, D is 14, and E is -8. It doesn't specify you need to show what they are. They've only asked that in this given form. So because of this function, I'm going to call this f of x, and I'm going to call this f of x, and we're done. So example 5, we're going to sketch a polynomial graph. Now, obviously it's very hard to work on this screen, so I'll be doing the legwork to get to this sketch, but I have pulled out the diagram itself. Okay, so remember the 4 things that I care about. I care about the degree, if it's positive or negative, its roots, and the y-intercept. So I'm going to take a look at what we've got and how from what we've been given. So this polynomial in factored form effectively. That's here. So this is a polynomial. If we multiplied it out, it would give us what we would be used to. However, I'm not going to spend a lot of time multiplying it out. It's not needed. I need to sketch. The form it's in is fantastic to allow me to sketch. So the first thing I'm going to do is I'm going to focus on the degree. So I'm just going to take my x part, so that's x, but take the squared, and I have x here. So what I have is I have x times x squared times x, which gives me x to the power of 4. It is also giving me a positive x to the power of 4, so therefore I can say that it is positive. If I got a negative, and it has happened in cases because the x maybe wasn't at the start of the bracket, and we will get our negative. So our roots. So given our factors of x minus 2, I know that that is x equals 2. I have 2 roots that are x equals 1 and x equals 1. And I have a third root, which is x equals minus 2. Last thing I need is my y-intercept. So I'm going to focus in on my constants. So there's my constant, don't forget your power, and my constant. So I have a minus 2 times minus 1 squared times plus 2. So that can all go into your calculator, and we should get a minus 4. So the point where we're going to cross the y-axis is 0, minus 4. So that allows me to have a really good idea of what I'm doing. I know I'm going to have 4 arms. I know where my roots are. I know where my y-intercept is. So what I would suggest to do first is draw out your x and y axis. The next thing I would do is I would draw my roots, or mark my roots. Then I would mark my y-intercept. I would then think about positive and what that means. And the positive, remember, means right arm up. And I would actually draw this starting on the right hand side and coming back. So I'm going to do a really rough sketch here, so you can get a sense of what I'm saying. However, I will show you what it should look like. So I haven't used rulers, I haven't spaced anything out. This is not the kind of sketch they're looking for. So here's my minus 2, here's my 1, and here's my 2. I have 0, oh apologies, this should be 0, minus 4. So I'm going to draw that down here. Okay, so what I like to do is I like to start on my right arm. So it's right arm up. So I'm going to start up here, and it's coming down through this. It's coming up. Now, remembering there's 2 roots here. So that means it touches it. It doesn't go through it. And it comes down to here. And it comes back up like this. So we have something like that. Now, what it actually looks like. Ta-da! So, obviously mine looks nothing like what the actual graph is, and the reason for that being that there are 2 points here in particular that I've messed up on, and it's this point here and this point here. And these, if you've already covered differential calculus, are called my turning points. So I have a little piece of information, sorry, so I'm rubbing this out, that I wanted to show up here. So the turning points are not important for this particular question, okay? However, if it was a differential calculus question and they have already asked you about the turning points, then that will be an extra piece of information you will be required to add into your sketch. Because of the fact that we don't know that, and it will be quite a lot of work to work through it to figure those 2 points out, all we're required to do and all they're looking for are the 4 pieces of information that I've given you above. The idea, does it have 4 arms? Is the right arm pointing up? Does it have the correct roots? Is the y-intercept shown? Okay. So example 1. Factorizing a cubic given a factor. So show that x minus 1 is a factor of x cubed minus 2x squared minus 5x plus 6, and hence find the other 2 factors. So let's take a look at this. So in order to show that x minus 1 is a factor, we use what is known as the factor theorem, which states that if x minus 1 is a factor, it will divide evenly into that polynomial, leaving no remainder. So we're going to do that division. We're going to do some long division. So x minus 1, and we're going to divide it into x cubed minus 2x squared minus 5x plus 6. So this goes in x squared time. So we have x cubed minus 1 minus 1x squared. And then we subtract. So remember your divide, multiply, subtract. So we're left with minus 1x squared. So minus 1x here. So we get minus 1x squared. Bring down the minus 5x. We get plus 1x. And we subtract. So plus, they cancel. And a minus. Minus 6x. Bring down your plus 6. And this goes in minus 6 times minus 6x plus 6, and then we come along and we subtract, so we do plus and we do minus. So that leaves me with 0, which means that therefore x minus 1 is a factor since it divides unevenly. So that's the first part done. Do make sure that you state this, answer the question. It says show that x minus 1 is a factor. So it isn't enough to just go into your long division. You do want to be putting in that statement at the end. So this is our answer here. So x minus 1 goes in x squared minus x minus 6 times. So to do the next part, hence find the other factors, we're going to take what we had, x squared minus 1x minus 6, and we're going to solve it. And we're going to solve that using the guide number method. So we're going to have minus 3 and a plus 2. So x squared minus 3x plus 2x minus 6. So x is common, x minus 3 plus 2 is common, x minus 3, x minus 3 is common, leaving me with x plus 2. Okay, so our factors are x minus 1, x plus 2, and x minus 3. So let's look at example 2, solving a cubic given a root. Show that x equals 5 is a root of 4x cubed minus 32x squared plus 68x minus 40 equals 0. So then they ask, hence find the other roots. The first thing we'll look at is the show that x equals 5 is a root. So in order to show that it's a root, we're going to sub in 5 for x. So we have 4, 5 to the power of 3 minus 32, 5 squared plus 68 by 5 minus 40 equals 0. So you can put that all into your calculator, simplify if you want, and you will get 0 equals 0. So therefore, x equals 5 is a root. So if we are given x equals 5 is a root, from this we can get a factor. So we know that x minus 5 then equals 0. Therefore, x minus 5 is a factor. So this is covered in more detail where in the video where it's looking at factors, roots, and sketching and drawing polynomials. So if you're still a bit unclear about roots and factors, that might be a video to watch to get a little bit of extra help on that before coming back here. So x equals 5 is a root, so x minus 5 is a factor. So in order to find the other factors, we must first divide x minus 5 into, so 4x cubed minus 32x squared plus 68x minus 40. So we have 4x squared, so we get 4x cubed minus 20x squared, and we subtract or change our signs, whichever way you want to talk about it, minus 12x squared plus 68x, so that goes in minus 12x times, so minus 12x squared plus 60x, so again change our signs, we have a plus here, a minus here, so we're left with 8x minus 40, and this goes in plus 8 times, where we get 8x, and 8 by minus 5 is minus 40, so again you want to change your signs, and we are left with 4x squared minus 12x plus 8. So basically the polynomial we were given can be rewritten as x minus 5 multiplied by 4x squared minus 12x plus 8. However, although we have two factors, one of those factors, and it's really this one here, is actually a quadratic, so it could be factorized further. So let's work on factorizing this further. Minus 12x plus 8. So our guide number here, so we're going to have a plus 32, and the factors of plus 32 that will work for us are minus 4, minus 8. So let's rewrite. So we have 4x squared minus 4x minus 8x plus 8. So 4x is common, x minus 1, and minus 8 is common, x minus 1. So x minus 1 is common, and then we're left with 4x minus 8. So we want to find the roots. So at this point we have the other two factors. So we have a factor is x minus 1 and another factor is 4x equals 8. But remember, this should equal 0. So we work on getting our factors down to our roots. So how we do that is we let each factor equal 0. So x equals 1. 4x minus 8 equals 0. So 4x equals 8. X equals 2. So the roots, and I'll just write it up here as our solution. So basically the roots are x equals 5, x equals 2, and x equals 1. So they're our roots. So let's look at example 3. Solving a cubic equation. So in example 1 and 2, we were able to use the fact that they had given us a factor or a root already to find the quadratic and then to factorize the quadratic. But in this particular example, they haven't given us this. They've just given us a straightforward cubic, and just told us to go solve it. So it would be useful if we were able to have that root or that factor. So what we do is we're going to use trial and error to find one of the factors. Well, actually rather one of the roots, which we will then turn into a factor. So it's important when we start one of these that we don't just start blindly going into this and thinking, oh, I'll just start subbing in 1 and minus 1 and 2 and minus 2. It's important to look at this number here. So this is minus 6. So one of the roots is going to be a factor of minus 6. Okay, so it's going to be a factor of minus 6. So let's look at that. So factors of minus 6. So we're talking about plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, so we should definitely have it within that. So if I basically look at, I'll try x equals 1. So I have 1 to the power of 3 minus 6, 1 squared, plus 11 by 1 minus 6 equals 0. So I want to verify that. So we're very lucky this time. We end up at 1 minus 6 plus 11 minus 6 equals 0, which basically gives me plus 12 minus 12 equals 0. So there x equals 1 is a root. Now we will not always be that lucky, and we would have to keep going. So let's just do x equals minus 1 just so we see what happens. So you'll have minus 1 to the power of 3 minus 6 by minus 1 squared plus 11 by minus 1 minus 6 equals 0. So this will be minus 1 minus 6 minus 11 minus 6 equals 0. So we have minus 12 equals 0. So we end up with minus 24 equals 0. So x equals minus 1 is not a root. So we use trial and error. Now you don't have to go into that much detail and show that much of your workings. You can do it on the calculator. What I will say about the calculator work is be very careful where you're working with the negative number. If you put into your calculator minus 1 to the power of 3, most calculators will give you back minus 1, which is the correct answer. However, if you're working with minus 1 squared and you write just minus 1 to the power of 2, they'll also give you back minus 1, which is not correct, because remember, anything squared should be positive. So be careful when you're putting it into your calculator. Really get used to using your brackets to help you with that. So now that we have one of our roots, so we have x equals 1 is a root, which also means then therefore x minus 1 is a factor. So now that we have a factor, we can do our long division. So I've just cleared this green here just so we have a bit more room. So what we have is we have x minus 1 is a factor. So now that I know one of the factors, I'm going to use my long division, divide this in to what I was given, so the cubic that I have here, and I should be able to get a quadratic, and then from that quadratic I should be able to factorize and solve, which will allow me to get all the 3 roots of the equation. So x goes into x cubed, x squared times, so minus x squared, so that's our divide, multiply, subtract. Okay, minus 5x squared plus 11x minus 5x minus 5x squared plus 5x plus and a minus, so those cancel, and we're left with 6x minus 6, and that goes in 6 times, 6x minus 6. So I'm going to just subtract, and they cancel, so we have a 0 remainder, which is what we're expecting. So x minus 1 is most definitely a factor. If at this point you got a remainder, there's 2 scenarios. You've either incorrectly found the factor, so the factor is not correct, or you've done something wrong in your long division. So you do have that fail safe. So now that I have my quadratic, I'm going to go along and solve that. So I have x squared minus 5x plus 6 equals 0. So I'm going to use my guide number here. So my guide number is plus 6. So I'm going to use minus 3 minus 2. So x squared minus 3x minus 2x plus 6 equals 0. So x is common, so we're left with x minus 3. Minus 2 is common, we're left with x minus 3. So x minus 3 is common, we're left with x minus 2. So to work from these factors back down to our roots, we let each of our factors equal 0. So we get x is equal to 3. And here we let this factor equal 0, and we get x is equal to 2. So therefore, the roots are x equals 1, which we got earlier, x equals 2, and x equals 3. Just be really, be really clear here about your answer, because often these can be quite long. So, be helpful to whoever is correcting your paper, and, try and make your work as clear as possible by showing your answer at the bottom altogether, especially if there's bits of it dotted throughout. So now we're going to look at a function and factor style question. So this is very much what we generally see with regards to a higher level style question. So I'm going to show you 3 different methods to doing this question. I'm going to do the missing factor method, which is nice but has a few tricks to it. Then I'm going to do a long division method, which is probably the one I would tell you to avoid unless you're very, very comfortable with long division. And the third method, which I think is possibly the easiest, but tends to be the one that maybe students don't recognize straight away, is using the idea of roots and getting simultaneous equations. So, first one, missing factor. So, I've been given 2 factors for a function. So, let f of x equals 2x to the power of 3 plus ax squared minus 17x plus b, where a and b are constants. Given that x minus 1 and x plus 4 are factors of f of x, find the value of a and the value of b. So I've been given 2 factors and my function is a cubic. Now, hopefully at this point everyone knows that a cubic does require 3 factors. So I have x minus 1 multiplying by x plus 4 multiplying by some other missing factor, and when I multiply them out I get 2x cubed plus ax squared minus 17x plus b. Now, what we generally let the third factor be is x plus k, because it's nice and simple. Generally k isn't in the question. If k is in the question, you have to use another letter. However, if I just stick in here x plus k, something is not right. Hopefully alarm bells will ring. And if you look at my 3 brackets, I multiply an x by an x by an x, and I get a 2x cubed. So no, it's not enough to just put x plus k. I also need this too. So in the case of using this method, watch out for the coefficient in front of that x cubed, because oftentimes when students try this method, they just do x plus k and then nothing works out because nothing is balancing up. So just watch out if a coefficient is required. Okay. So now all we're going to do is multiply out our 3 brackets and equate the terms as we have been doing before. So I'm going to multiply 2 at a time. So I'm going to leave that one as is, and I'm going to multiply these together. So you can work it out the long way. I'm just going to quickly jot it down. 8x kx. Okay, and that equals 2x cubed plus ax squared minus 17x plus b. So we need to multiply this out. So you get 2x cubed plus 8x squared plus 4kx plus kx squared minus 2x squared minus 8x minus 4k minus kx. Okay, and that still all equals 2x cubed plus ax squared minus 17x plus b. Okay, so we've a lot going on here. Just taking a quick look, can anything be cleaned up? So I can see we have an x squared here, but kx squared, but I have an x squared here that I could clean up. Other than that, unfortunately, everything will have to stay. So you have 2x cubed. I have 8x squared minus 2x squared, so I get plus 6x squared. I'm just going to put the plus kx squared up beside that here. I then have a plus 4kx. Oh, and I have a minus kx. Actually, I'm going to rub this out. Apologies. I didn't spot that. So I have a plus 4kx and a minus kx. That does clean it up a little bit for me. So I get a plus 3kx and minus 8x minus 4k. So now everything's nice, it's in order, and it's simple as possible. So we're going to equate our terms. So x cubed terms. Now, if you had forgotten to put that 2 into our extra factor, this is where you'd see the problem. You'd have x cubed equals 2x cubed, and that's not true. Now, there it's not very helpful at all, but at least we know we were correct. So now let's look at our x squared terms. So our x squared terms, we have 6x squared plus kx squared, and that equals, clean all this up, equals ax squared. Okay, and the x squareds can be ignored. I then have my x terms. So my x terms are 3kx minus 8x, and that all equals to minus 17x. So my x's cancel, and actually straight away here I can work out what k is. So I will work that through. The reason I didn't work through the x squared is because I had a k and an a. So I bring my 8 across, so I have minus 17 plus 8 equals minus 9, therefore k equals minus 3. So I can actually go back here and say 6 minus 3 equals a, so a equals 3. So there's one of my answers straight away. And now I just need to work out my non-x terms. So they're my constants, but I think calling them your non-x terms, students tend to get on a little bit better with them because they remember, well, actually it's not about the letters, it's about the ones that don't have the x. So minus 4k equals b. I already know that that's minus 3. And I get b equals 12. Great, so I found my value for a and my value of b using the missing factor method. So letting 2x plus k being the missing factor, working it through, a lot of multiplication, but very much the traditional style of the unknown coefficients question.